Good morning, student. Today I'm going to be doing some revision for the material science, and the revision would be having set equation. The set equation, this should you should be able to answer all the set equation which is concerning. Maybe you would have one or two from them in the exam. This we start with some question related to the topics, talking about materials. The first question, she stated, what is a material that's used in pipelines to transfer oil from place to another? And the answer would be, of course, you got a multiple choice answer question, and the answer for this question would be cast iron. Cast iron is one of the most durable materials. It's used a lot into into heavy industries where you could be transferring oil, transferring water, and so on. And mainly this is because the ability of the cast iron to resist corrosion, to resist chemical reaction, and as well for the thermal expansion. The material is very stable. Okay. The second question, which is stated that what would you use why would you use the cast iron as a material? As I mentioned earlier, the durability of the materials is very important, and plus its ability to resist all the corrosion, to resist, so the materials could stand all the environmental problem for a long time. Question number 3, which is stated, how is it being made? The material of cast iron, and from the name cast iron, the material obviously is being casted. So sand casting is a famous method for making pipes and so on. Question number 4 is asking about the materials the chisel would be made of. In here I want you to distinguish between the high carbon steels and low carbon steels. Material which is suffer from impact action, or you could hammer it into zinc, which is you need to have a high impact. So chisel would be made of high carbon steels due to the ability to stand high impact resistance. Then in the second question, we were looking into a material which will be made of low carbon steels, like the screws, nuts, material which doesn't suffer from high impact most of the time. So pretty much all that sort of the failures it would happen on most of this, it would be fatigue due to vibration, and it could stand that. So most of the consumable materials used pretty much is made of low carbon steels. Then talking about question 6, we're talking about what is most of the crockeries, most of the kitchens, the surface of fast food kitchen, what is it made of? Pretty much most of this application would be made of stainless steels, because the ability of stainless steel to resist the staining or resist any scratch on it. So stainless steels is one of the iron-based materials which have a level of carbon between 0.1 to 0.2%, and it resists a lot of the corrosion, and it resists staining. Then talking about the question number 7, what is the material the air conditioning pipes is made of? So is an alloy, is some sort of copper alloy, and it's mainly made of copper as the main ingredients, and maybe tin or zinc as a alloying sort of ingredients into the copper. Then question number 8, why copper are used in electrical insulation? Copper is one of the materials which is fall in very high in the galvanic series, which have ability to conduct electricity and heat in a good condition. So that's why copper is always become is a compatible material when it comes to the electrical conductivity. Then talking about lattice structure, you have three types of lattice structures we learn about: body centrocubic, face centrocubic, and hexagonal closed back. Each one of them which should represent a form where the metals are being shaped, and the face centrocubic, this is what would represent the aluminium, tin, and maybe copper. All these type of materials would be face centrocubic, due to, like, most of the grain structures which is being packed around the face of the material. So the material would be less dense, but it would have sort of, according to the physical properties of the material of face centrocubic, would be shiny and less weight would be on it. And body centrocubic, this is a type of materials which is like, heavy materials, denser materials like cast iron and chromium and so on. And this type of materials which is really heavy and is less shinier than face centrocubic. Then talking from question number 12, so of course is mentioning all this and talking about the structures. What's the type of structures of the thermoblastic? Thermoblastic fall into the two shapes of structures of general plastic, which is amorphous and crystalline. Thermoplastic takes the both form depending on the application. So many plastic materials could be changed from one form to another, say like PVC for example. Rigid PVC, you see it in the windows, you see it in the pipe lines, but as well you could see a PVC, plasticized PVC, which is like, it could be in like a leathery type sort of clothing. So it takes the two forms, amorphous and crystalline, in so many cases. And when it comes to the thermosetting, takes one form, which is amorphous, because the cross-linking reaction makes the structure of the thermosetting is not organized, and it doesn't have a certain order. So thermoplastic most of the time is amorphous. Then talking about what's the forces applied into the materials, you should know about all the forces the materials could be sustained. When material is being pulled in both direction, this is called the bending. When the material is pushed into same axis of the forces but against each other, those forces would be acting against each other. This is called compression. And then when the material is being twisted, this is called twisting action. And of course, you have bending, you have fatigue, you have a different application of failures what the materials experience, and you should be aware of. Metals and non-metals, you should be aware what is the metals and what's the non-metals. And according to the periodic tables, most of the materials falling at certain part of the periodic table will be classified as the metals, and certain materials classified as gases and liquid, and you should be able to distinguish between each one of them. So in here you've been given a question of metals and one non-metals, and you should distinguish. Copper is a metal, steel is a metal, iron is a metal, tin is a metal, PVC is a plastic material which is classified as non-metals. Which of the materials as well is classified as non-ferrous? You should be distinguished between ferrous and non-ferrous. Ferrous is the most of the materials which have the ability to conduct, to be magnetized or to attract the magnets, but non-ferrous is a material which doesn't have the ability. Of course, most of the iron materials have the ability to be a ferrous. Iron, steel, cast iron, low carbon steel, all of it, plus cobalt, are all ferrous, and any other type of materials in the periodic table which are metals, they are not non-ferrous. Which one is not part of the mechanical properties? Of course, you should know all the mechanical properties and the physical properties and distinguish between two of them. Mechanical properties is stress, strain, elasticity, strength, ductility, brittleness, and so on. And when it comes to the physical properties, you have density, volume, colors, and so on. And then here you have density. So density is the only one which is a physical property, not mechanical properties. Which one is not part of the physical properties? So here you have color, volume, mass, boiling, brittleness. Brittleness is the mechanical properties. Boiling, mass, volume, color, all are physical properties. Then you should be able to distinguish in the stress strain curves and what's the difference between different mode and different zone. And in the stress strain curve, you've been asked what materials is exceeded. If the materials exceeded the yield strengths, what zone would it be? If a material exceeded the yield strengths, then the material would be on the plastic zone, which it cannot be coming back to its originality. And if the materials below the yield strengths, these materials would be in the elastic zone. So if it's the force being released, the material would come back to its originality and it would have the same form which it started with. What is the high stress value called? The high stress value called is ultimate tensile strength, and this is where you, when you material selection, you would be looking into ultimate tensile strengths of the materials, whether the materials would be standing the tension or standing compression. Based on the application of material will be applied on. Ultimate tensile strength is indicators which shows the material is capable to stand a high force applied into it. What is the name of deformation before yield strength? This is mentioned earlier. This is called elastic deformation, which is the materials before reaching yield strength, it would come back to its originality. And the opposite to that, when exceed the yield strength, is a plastic deformation, with the materials reach plastic, it would never come back again, and will be considered as deformed. Okay, the gradient of the slope in stress strain curve is called the Young modulus, or some people refer to it as the stiffness modulus or modulus of stiffness, whereas the equation for the modulus of stiffness is the stress divided by the strain, and this has to be happened before the yield strength, because as soon as the material reaches yield strength, then the curves start taking a different form, and is in different materials you have to suffer two yield strengths, like plastic materials. So this beyond the yield strengths, the curve won't be as accurate as it is below the yield strengths. Thank you very much.